Something unprecedented has just entered our solar system. It's moving faster than 200,000 kilometers per hour. It glows in ways no comet ever should, and its trajectory is so precise, some of the world's leading scientists are daring to ask a question humanity has never been ready for. Could this be alien technology? This mysterious object is called 3I Atlas, and what's happening right now could change our understanding of the universe forever. The closer we look at this visitor, the stranger the story becomes. Welcome to Quantum Leap. If you love exploring the greatest mysteries of space, the latest discoveries, and the questions that might redefine humanity's place in the cosmos, hit like, subscribe, and ring the bell. Because today we're diving into one of the most fascinating and unsettling space events of our time. On July 1st, 2025, astronomers using the Atlas Sky Survey in Chile detected a faint moving object. At first, it seemed like another icy body drifting toward the sun. But calculations quickly revealed something unusual. Its orbital eccentricity, the measure of how stretched its path is, was greater than 1. That means it wasn't bound to the sun. This object came from interstellar space, and once it swings past, it will leave our solar system forever. That makes 3I Atlas only the third confirmed interstellar object in history. The first was the now legendary Oumuamua, discovered in 2017, followed by the comet Borisov in 2019. At the time, scientists estimated we might detect such an object only once in several decades. Yet here we are, less than 10 years later, staring at something stranger than either of the previous two. When Oumuamua passed by, it shocked astronomers with its elongated, cigar-like shape and puzzling acceleration that couldn't be explained by gravity alone. Borisov seemed more familiar, behaving much like a classic comet. But 3I Atlas has arrived as something in between, and at the same time, something completely new. The first clue that this wasn't a normal visitor came from its brightness. Observations from the Hubble Space Telescope revealed that its glow fades far more steeply than that of a typical comet. Normally, brightness is assumed to come from reflected sunlight. If you know how bright an object appears and you assume a standard reflectivity, what astronomers call albedo, you can estimate its size. Using this method, 3I Atlas should be enormous, close to 20 kilometers in diameter. That would make it nearly 40 times bigger than Oumuamua and far beyond what scientists expected to find drifting between the stars. For comparison, Halley's Comet is just 11 kilometers across. Even the spectacular Hale-Bopp, which lit up Earth's skies in the 1990s, was about 60 kilometers. The odds of such a giant rock randomly wandering into our solar system are almost zero. And that's when a provocative idea was raised. What if 3I Atlas isn't reflecting light at all? What if it's actually producing its own light? Harvard astrophysicist Avi Loeb, famous for suggesting that Oumuamua could have been alien technology, proposed that this brightness pattern matches what you'd expect from a self-luminous object. If that's true, then 3I Atlas might not be a 20-kilometer colossus at all. It could be just a few hundred meters across, small enough to be plausible but strange enough to demand new explanations. So what could cause an object to glow by itself? One possibility is radioactive decay from heavy elements inside, releasing energy as light. Another is residual thermal emission, heat trapped inside the body that continues to radiate outward. But here's the problem. To shine at the level we're observing, 3I Atlas would need to generate around 10 gigawatts of continuous power. That's equivalent to several large nuclear power plants running non-stop. Sustaining that for millions of years of interstellar travel is virtually impossible under natural conditions. And that's where things take a turn toward the extraordinary. If natural explanations fall short, we have to at least consider the possibility of artificial illumination. Imagine a spacecraft designed to shine across the void, or a probe whose systems produce detectable light as a byproduct. Some researchers even suggest the ice and dust surrounding 3I Atlas might not be native to the object at all. Instead, it could be cosmic debris accumulated over millions of years of travel, a kind of camouflage, making a technological artifact appear like an ordinary comet. It sounds like science fiction, but the orbit of 3I Atlas makes the mystery even harder to ignore. When astronomers mapped the path of 3I Atlas, they discovered something remarkable. Instead of plunging in from a random direction, its orbit lies just 5 degrees off the plane where the planets orbit the Sun. That alone is unusual. Most interstellar objects should arrive at random angles, since stars in the galaxy move relative to each other in all directions. But the surprises didn't stop there. On October 3, 2025, 3I Atlas will pass within 29 million kilometers of Mars. At the end of October, it will reach perihelion, its closest point to the Sun, at a distance of 1.35 astronomical units. At that very moment, Earth will be on the opposite side of the Sun, unable to observe it because of solar glare. Later still, it will swing within 33 million kilometers of Jupiter. The odds of a random interstellar object making such well-timed encounters with 3 major planets are estimated at just 1 in 20,000. To Avi Loeb and his colleagues, that alignment is more than coincidence. They describe it as potentially resembling a reverse solar O-berth maneuver, a clever trajectory where a spacecraft uses a close pass to a star not to speed up, but to slow down, allowing it to remain inside a new system.
In human terms, spacecraft like Voyager or New Horizons used gravity assist to slingshot faster. But in theory, a vehicle could do the opposite: burn its engines near a star to brake and capture itself. And if you were trying to avoid detection from Earth, timing your closest solar pass so that the Sun blocks all our telescopes would be the perfect way to remain hidden. Coincidence or design? Of course, not everyone agrees. Most astronomers urge caution. Professor David Jewett of UCLA points out that 3I Atlas is showing all the hallmarks of an active comet. Its dust production, between 6 and 60 kilograms per second, fits right within normal cometary activity. The ejection speeds of its particles, ranging from 20 to 2,000 meters per second, also match what we see in the solar system. And the absence of detected gases so far isn't strange either. At 4 astronomical units from the Sun, the distance of Jupiter, many comets remain quiet until solar heating intensifies. This echoes the debate over Oumuamua. Back then, Avi Loeb argued for alien technology, while most of the community insisted on natural explanations. The same fault line has opened again. Loeb warns that ignoring anomalies is bad science, while his critics argue that extraordinary claims demand extraordinary evidence. To them, invoking alien probes without proof risks turning astronomy into speculation. Still, even the skeptics admit that 3I Atlas is unusual. It behaves like a comet in some ways, but its brightness, orbit, and alignments remain difficult to dismiss. The coming months will be critical. In October 2025, as 3I Atlas passes near Mars, scientists are discussing the possibility of using the Mars Reconnaissance Orbiter and its high-res camera to capture high-resolution images. That could provide our first close-up look at an interstellar object's surface and reveal whether we're seeing reflected sunlight or something else entirely. By December, it will make its closest approach to Earth, offering one final opportunity for telescopes worldwide to study it before it disappears forever into interstellar space. If it turns out to be natural, it will still rewrite our understanding of what interstellar comets can be. If it turns out to be artificial, it would be the most important discovery in human history. But the story doesn't end there. Even if 3I Atlas proves to be entirely natural, its arrival marks the beginning of a new era in astronomy. The Vera C. Rubin Observatory has just begun operations. This revolutionary telescope will scan the entire southern sky every few nights with unprecedented sensitivity. Scientists expect it to discover dozens of interstellar objects every single year. That means events like this won't be once-in-a-generation surprises anymore. They'll be routine, and that's transformative because once we have a statistical sample of dozens or even hundreds of interstellar visitors, we'll know what's normal, and we'll immediately recognize what isn't. If most are icy comets like Borisov, then 3I Atlas will stand out even more. But if others show the same suspicious brightness or improbable orbits, then we may be looking at patterns that hint at something extraordinary. Each of these visitors is a messenger from another star system, carrying clues about how planets form, how water and organics are distributed, and perhaps, just perhaps, whether intelligent life has left its mark beyond its home. So now, I want to hear from you. Do you think 3I Atlas is just a strange exotic comet? Or are we witnessing the first real evidence of something artificial passing through our skies? Leave your theories down in the comments, I'll be reading them all. And if you're fascinated by the mysteries of the universe and want to stay ahead of discoveries like this, make sure you hit like, tap subscribe, and join the Quantum Leap community. Together, we'll keep pushing beyond the limits of what we think we know. Here on Quantum Leap, we don't just follow the stars. We chase the questions that could redefine humanity's place in the universe. Until next time, keep your eyes on the skies, because the next great mystery may already be on its way.